Welcome back students to standard 10th physics. It's chapter 10 light, reflection and refraction, and we are in the 10th session now. So far we completed 9 sessions in which we learnt about reflection. We learnt about reflection of light, correct? And in this reflection, what we learned, children? 1. Definition of reflection. Next, laws of reflection of light, correct? Then mirrors. Yes, we learnt about the mirrors. 2 types of mirrors. One, the plane mirror, and other the curved mirror or spherical mirrors. These spherical mirrors, they are curved mirrors, are of 2 types: concave mirror, convex mirror, correct? Then the image is formed in this mirror. How do plane mirror forms image? How do the concave and convex mirror forms image? We place object at different positions in front of these mirrors and then observe the nature of image, the size of image, alright? Okay, and the position of image formed when object is placed, okay, in front of this mirror. Then what we learned? Yes, we learned about mirror formula and magnification. Of course, we also learned one thing: Cartesian sign convention. Cartesian sign convention for mirrors, correct? Cartesian sign convention for mirrors. So all these things we learnt in reflection. Now we are going to learn about refraction, the another phenomenon of light. Alright? Same. We are going to learn its definition. We are going to learn the laws of refraction, not reflection. Now we are going to learn the laws of refraction. Alright? Instead of mirrors, we will have lenses. Right? Lenses. Yeah, lens. Okay. Then, yes, we are going to learn about only the curved lens. No plain lenses would be there. Alright? Then curved lenses, matlab lenses. There will be 2 types of lenses. One is concave lens and other is convex lens. How images are formed in these lenses when objects are placed at different positions in front of these lenses. That we are going to see. Instead of mirror formula, there will be lens formula. Yes, there will be magnification for lenses also, and Cartesian sign convention for lenses. Earlier we saw Cartesian sign convention for, alright, Cartesian, I-A-N, Cartesian sign convention. Is that clear to you? We will see for the lenses as well. So this is all that we are going to see in refraction. Now the first thing, what is refraction of light? Children, light travels from one transparent medium to another transparent medium. Alright? Yes. Now what do you mean by transparent medium? Air, it is transparent. It is one medium. Glass, yes, if it is transparent glass, because colored glasses, they may be translucent. I am talking about only the transparent glass, no colored glass. Okay. Then water, clean water, clear water, that is also transparent. Okay. So these are transparent medium, and light can travel from one transparent medium to another transparent medium. Let's see how light travels from one medium to another medium. This is a thin plane. This is thin plane. Alright? Which separates one transparent medium air from another transparent medium glass. Alright? We'll see what happens when light travels from one medium to other. From air to glass or from glass to air. Alright. Children, you know how the light travels. You know, light always travels in a straight line. Correct? This is medium is only till here, the separation. Here this is air only. In air, you can see the light travels in a straight line, or only in glass. Sir, glass it will travel in a straight line. Alright? Okay. Children, this plane, thin plane, it separates air and glass. Try to understand. Here, the contact between two transparent media takes place. So you can say thin plane of air and very thin plane of glass, they coincide. And that is the plane, that coinciding plane is the plane separating one transparent medium from another transparent medium. Children, this plane which separates is called interface. उसे क्या कहते हैं? Interface. So here black horizontal line represents interface. Now children, let's say one light ray is traveling in air this way. This is air medium and now it is going to enter the glass medium. Correct, children? Okay. Now since this air is traveling from one medium to another medium, as long as it is in the first medium, it is called incident ray. It is called incident ray because it is traveling towards other medium. Reflect and incident ray in case of reflection is the light which is traveling towards the surface of the object. Light which is traveling towards the other medium. Alright. Now you know the medium changes, children. Here it's air and now the light is going to enter another medium, glass. You know, you expect the light to propagate straight. You expect the light to propagate straight. आपको तो ऐसा ही होगा मन में कि ये लाइट सीधी चली जाएगी. No, children. At this point of incidence, the light ray bends a little. This is the light ray which is propagating away from air. Correct? This is called refracted ray. This is called refracted ray. Alright? Okay? Did you understand, children? So, children, when light travels from one transparent medium to another transparent medium, it bends at the point of incidence. This phenomenon is called refraction of light. Is that clear to you? Okay. So, got the definition of refraction of light. Now we are going to see the laws of refraction of light. What is this? Yes, it's a glass slab. Correct? It has 6 faces. Each face is rectangular. Alright? I hope you can see it because it is transparent. You may not be able to see properly. Alright? That is glass slab. And here is prism. It has 5 faces. 1, 2 and 3. The bottom one. They are rectangular faces. This is the rectangular face, rectangular face, rectangular face. So out of 5 faces, they have 3 rectangular faces and 2 triangular faces. Alright, children? Okay. So we are going to study the laws of refraction using these 2 devices. One is glass slab and other is prism. Alright. Let's see how refraction takes place in glass slab. Alright, children. So are you ready to see the activity? Simple experiment which I am going to demonstrate here. Yes, you will need your imagination to understand it. Okay? Yes, we are going to derive the laws of refraction of light using glass slab. Okay. So on a big table, we'll place a white sheet and on that we are going to put the glass slab and then mark its position. Uski position हम mark कर लेंगे. So this is how we are going to get its position. हम बोर्ड पे देखेंगे तो ऐसा ग्लास स्लैब पाएंगे उसकी पोजीशन. All right, this is glass slab. Let's say A, B, C, D. Alright. Now, children, I'm going to put a laser torch. You must have played with laser beams, laser rays. A very small torch. બરાબર એક નાનું રમકડું જે લેઝર બીમ પ્રોડ્યુસ કરે છે એ તમે જોયું હશે, right? Now I'm going to place that torch on the surface. All right, and when I switch on the light, yes, laser rays will come out. All right, आपको रेड कलर की लेजर रेज दिखेगी and it will not travel straight. Children, जो रे आने वाली है वो ऐसे सीधी नहीं जाएगी. When you take the aerial view after switching on the laser torch, all right, you will be able to see this. आप वो ray of light रेड कलर की सीधी जाती नहीं देखेंगे. It bends here and then it bends here, and this is how the bending will occur. This is your observation. All right, आप ऊपर से देखोगे, एरियल व्यू मीन्स व्हाट, आप ऊपर से देखोगे तो वो रे ऑफ लाइट सीधी नहीं जाएगी, वो ऐसे बैंड होगी, फिर ऐसे बैंड होगी. आर यू गेटिंग मी? यस. नाउ दिस रे ऑफ लाइट शुड हैव ट्रैवल्ड स्ट्रेट लाइक दिस. उसको तो ऐसे सीधा जाना चाहिए था, बट वो ये बाजू बैंड हुआ. अब ये रे ऑफ लाइट की बात करो, जो ग्लास में है उसको ऐसे सीधे निकल जाना चाहिए था, लेकिन वो इस तरफ जा रही है. करेक्ट चिल्ड्रन? सो दिस इज इंसिडेंट रे, दिस इज रिफ्रैक्टेड रे, दिस इज रिफ्रैक्टेड रे, दिस इज इंसिडेंट रे. अब व्हेन यू टॉक अबाउट ग्लास, आप जब ग्लास से शुरुआत करेंगे तो ग्लास के लिए दिस इज इंसिडेंट रे, इंसिडेंट रे. और जो एयर में, फिर से एयर में बाहर निकली, दैट इज रिफ्रैक्टेड रे, दैट इज रिफ्रैक्टेड रे. सो व्हेन वी स्टार्ट विथ एयर, व्हेन वी स्टार्ट विथ एयर, दिस इज ग्लास एंड दिस इज एयर अगेन. सो व्हेन वी स्टार्ट विथ एयर, the ray of light in the air is incident ray. When it enters glass, it is refracted ray. When we start with glass, the ray of light traveling in glass is incident ray. But when it enters air, the second medium, the ray of light traveling there is called refracted ray. Lekin in this experiment, we call this as incident ray. Correct? This as refracted ray. And this one as emergent rays. It is called emergent ray. Why it's called emergent ray? Yes, ray of light enters the glass and then comes out of the glass here. It makes exit from the glass here, emerges out from the glass. That's why it is also called emergent ray. Now we are going to observe what is exactly happening. This is incident ray and AB is interface. AB is interface. Interface means the thin plate which separates air and glass media. Alright, here is the point where the ray of light gets incident. At that point, I am going to draw normal to interface, perpendicular to interface. So this is normal, perpendicular. Alright. Now, angle between normal and incident ray is called angle of incidence. Angle of incidence. Alright. And the angle between refracted ray and the normal, that is called angle of refraction. Angle of refraction. Is that clear to you? Now, are angle of incidence and angle of refraction equal? No. एक्चुअली ये रेड डॉटेड लाइन के साथ ये और ये इक्वल है. ये तो एंगल हैज बिकम लिटिल स्मॉलर बिकॉज द लाइट हैज बेंट. करेक्ट? सेम वे हियर व्हेन यू टॉक अबाउट और व्हेन यू स्टार्ट विद ग्लास मीडियम, दिस इज इंसिडेंट रे. एज आई सेड, उसको इंसिडेंट रे कह सकते हैं. एंड दिस इज द पॉइंट ऑफ इंसिडेंस. एट द पॉइंट ऑफ इंसिडेंस, या, एंड द इंटरफेस विल बी CD. At the point of incidence, I'll draw the normal. Okay, this is normal, normal 1, normal 2. Alright? This is angle of incidence and this is angle of refraction. देखो ये एंगल और ये डॉटेड लाइन, रेड डॉटेड लाइन, ये दो एंगल वर्टिकली ऑपोजिट होते हैं तो दे आर इक्वल, लेकिन यहां तो एंगल ऑफ रिफ्रैक्शन बड़ा है, इट हैज बिकम बिगर. करेक्ट? सो चिल्ड्रन, what is happening here? First, this is how light is going to travel when it travels from air to glass and from glass to air. It bends at the point of incidence and this phenomenon is called refraction of light. So what is refraction of light? When light travels from one transparent medium to another transparent medium, it bends at the point of incidence. This phenomenon of light is called refraction of light. Now let's see the laws. You will get all the laws here. Children, see the incident ray, normal ke left mein, and see the refracted ray, the blank one, normal ke us taraf. So just like the reflection, the incident ray and reflected ray are on the opposite side of the normal. Here, the incident ray and refracted ray, they are on the opposite side of the normal. Children, ये जो है मिरर है, ये है इंसिडेंट रे, ये है रिफ्लेक्टेड रे और यहां नॉर्मल. सो इंसिडेंट रे एंड रिफ्लेक्टेड रे, दे आर ऑन द ऑपोजिट साइड ऑफ द नॉर्मल, बट बोथ आर इन द सेम मीडियम एयर. ये भी एयर में है, ये भी एयर में है, लेकिन हियर इफ द इंसिडेंट रे इज इन फर्स्ट ट्रांसपेरेंट मीडियम, then refracted ray is in the other transparent medium. Incident ray air में है, refracted ray glass में है, because it enters from one medium to another. So first law of refraction of light, the incident ray and refracted ray, they lie on the opposite side of the normal and in different media. They lie on the opposite side of the normal and in different media. Now you see. Children, this ray of light, incident ray, was supposed to travel in this direction and the normal is here. Normal से इतना दूर उसको जाना चाहिए था, but because of change in media, medium change हुआ, इसलिए it bends और एंगल इतना हो गया. So एंगल छोटा हो गया. Angle between the refracted ray and normal has become small. So you can say, yes, ray of light has bent, या bent तो हुआ ही है, bent towards normal, towards normal, वो normal की तरफ bend हुआ. Alright, अब यहां देखो, this incident ray जो ग्लास में है, it should have traveled straight like this, मतलब यहां से जाना चाहिए तो उतना उसका एंगल ऑफ रिफ्रैक्शन होने चाहिए था, लेकिन वो तो इतना बड़ा हो गया. So angle of incidence has increased. So here you can say ray of light जो रिफ्रैक्ट हुई has bent away from normal, has bent away from normal. Are you getting me, children? This ray of light has bent away from normal. So that is the second law of refraction of light. Air is thinner medium, so rarer medium. Glass is thicker medium, so denser medium. Air thin है और glass thick है, so air is rarer medium, glass is denser medium, and again air, so it is rarer medium. So the second law, when light ray travels from rarer medium to denser medium, it bends towards the normal. It bends towards the normal. And when ray of light propagates या travels from denser medium like glass to rarer medium like air, it bends away from the normal. It bends away. This is the second law of refraction of light. Is that clear to you? And the third, incident ray, refracted ray and normal. They always lie in the same plane. They always lie in the same plane. That is same for even reflection of light. So I hope you have understood. Good. Alright children, so what have we seen in this session? Of course, definition. When a ray of light, the red one, propagates from one transparent medium, air, to another transparent medium, glass, it bends at the point of incidence. See, red ray is incident ray, blue ray is refracted ray, and it bends at the point of incidence. This phenomenon of light is known as refraction of light. Correct? Now, laws of refraction of light. Alright, the incident ray, that is the red ray, and the refracted ray, that is the blue ray, always lie on the opposite side of the normal. This is normal. To the left is incident ray, to the right is refracted ray. If you consider this blue one as the incident ray in the glass, then the green one is the refracted ray. Here is the normal. Yes, blue ray is to the left of normal, green ray is to the right of normal. Okay. And in different media. Yes, the incident ray is in air, the refracted ray is in glass. If you consider incident ray in the glass, the refracted ray is in the air. Correct? So that is the first point. When the light travels from rarer medium like air, it is traveling, the red one is in rarer medium air. When it is traveling from rarer medium to denser medium, it bends towards the normal. Alright? While when it travels from denser medium, that is glass, to air, you can see it should have traveled in the direction of dotted line, but it bends away, dur jata hai. So it bends away from the normal. The incident ray, the red ray, the normal, that is the pencil work, and the refracted ray, they always lie in the same plane. If you consider a blue ray as the incident ray, normal is here, and green ray, the refracted ray, then they all lie in the same plane. So these are the three laws of refraction of light. Few points to be noted here. A ray of light incident normally or perpendicular does not bend but travels straight from one transparent medium to another. That I have not discussed, but I am putting it here. This is the incident ray. Children, this green ray is the incident ray. Now it is normal. It is perpendicular to that what we call interface. Interface, correct? It is normal to the interface. So what happens? No bending takes place. It will travel straight. Now in the glass, this is also perpendicular. So without bending, it travels straight. So when a ray of light is incident, perpendicular to the interface, then there is no bending, though the light travels from one medium to another medium. Both the mediums are different. Is that clear to you? So that is the point. A ray of light incident normally or perpendicular does not bend but travels straight from one transparent medium to another. Remember this. When the ray of light travels from rarer medium to denser medium, the angle of refraction becomes smaller than the angle of incidence. Children, now look here. Angle between the normal and the incident ray is angle of incidence, and the angle between this normal and the dotted line, if it doesn't bend in absence of media, if there are no two different media, then it would have traveled straight. Then these are vertically opposite angles, correct? So they are equal. But what is happening? The angle is reducing because of bending when light travels from air to glass. So because of bending, the angle reduces. So when the ray will bend, yes, if it is traveling from rarer medium to denser medium, it bends towards the normal. Now look here. This ray of light would have traveled along the straight dotted line path if there was no different media here. Alright? But it is bending, and it bends to move away from the normal. Initially, these two angles are equal, but then this is wider angle, bigger angle. Alright? So that is the point here. When a ray of light travels from rarer medium to denser medium, the angle of refraction becomes smaller. ये छोटा होता है. And when it travels from denser to rarer, the angle of refraction becomes larger. When a ray of light travels from denser medium to rarer medium, the angle of refraction becomes larger than the angle of incidence. And the last one, the incident ray and the emergent ray in case of glass slab are parallel to each other. Look, this. I am drawing pencil line. Alright, this is incident ray. And this is emergent ray. They are parallel to each other. So incident ray and the emergent ray in case of glass slab are parallel to each other. Children, now how much bending take place? We exactly don't know. But while drawing the figure, you must take care that this ray and this ray are parallel to each other. Alright? Fine. So that's all in this session. See you in the next session. Till then, goodbye.